Hello guys, so today we will be starting another very new chapter, that is mensuration, and we will be starting with area of triangle. So in this we are going to understand first how to calculate the area of triangles, and then we are going to implement those formulas or those concepts rather in different problems that have been asked from this part. So we will be starting straight away with area of triangle. At this point of time, I am pretty hopeful that many of you know the area of triangle formula, that is half into base into height. Even if you don't know, you can see what is written on the board and you can just please write it down, and we are going to discuss mainly on how this formula comes and we are going to derive this formula. So at this moment we are going to concentrate on y. So let's start. So as you can see over here, a triangle is drawn, and in this triangle I have dropped a perpendicular from one of the vertex, right. This is the vertex, I have dropped a perpendicular from the vertex. This perpendicular from any vertex, remember, perpendicular from any vertex will always be called as height of that triangle. So you may ask, sir, this is the height, can there be any other height of this triangle? Yes, there can be any other height of this triangle. If you take this point, say, and if you want to draw a perpendicular, so I will draw a perpendicular with some other color which will look good. So if I draw this perpendicular and name it, say, BE, so if this is the perpendicular, so BE also is the height of the triangle. So this height and base will be written on basis of from which point you are drawing the perpendicular. Like over here what I did is I drawn the perpendicular from A. So the height is AD, I have marked it, height is AD. The base is BC, because the height that has to be taken should be perpendicular to the base. Okay, the height, which height you will take? The height that is perpendicular to the base. So first of all you have to select the base. So I have selected the base as BC, and opposite to that base there is a vertex, that is A. From there I have dropped a perpendicular on BC which is named as AD, and so my height is AD and BC is my base. On the other hand, if I would have taken AC as my base, then I would have to look for the vertex opposite to the AC which is B, and from B I have to drop a perpendicular BE. In that case the base will be AC and perpendicular will be BE. So that is the concept of height and base in case of triangles. So I hope you have understood that. So now I am going to proceed on to how this formula came into existence and why are we going to use it. See, we will be discussing a little bit of rectangle over here. So we know very well that in case of rectangle the area is equal to length into breadth, we know this, right. So here in this rectangle the diagonal is AC, you know the diagonal is AC, and in rectilinear figure chapter you must have studied that this triangle ABC and ADC on the other sides of the diagonal will be congruent in nature. You can also prove it. See, in rectangle all the sides are perpendicular to each other, so this is also 90 degrees. So one angle is equal, one is common side, so hypotenuse is same and opposite sides are equal. So it is very easy to prove that in a rectangle the triangles on the other sides of the diagonal is congruent in nature. What does congruent mean? Congruent means that both this triangle will be exactly equal in all the parameters, whether it be angles or sides in magnitude, right. So triangle ABC and triangle ADC are equal in all respects. So we can clearly see that if this triangle and this triangle are absolutely equal, then area of this triangle and area of this triangle will be equal to area of the rectangle. So if these two are equal, suppose if I say area of area of triangle ABC is x, that means this part will have an area x. So, if this part has an area x, then definitely this part will also have an area x, clear. So, both this have an area x. Okay. So, if I want to calculate area of triangle ABC, what I have to do? Triangle ABC's area is equal to half of area of ABCD, because this and this part is equal. So, this and this will be individually equal to half of the area of rectangle. So, what is the area of rectangle? Area of rectangle is length into breadth, you know that very well. So, what is length over here? AB. So, half into AB. What is breadth over here? BC. BC. So, AB and BC is clear now. So, what is this? If you see this triangle, this BC is height, right? This BC is height. This BC is height, and this is nothing but base. So, basically the formula half into base into height is proven now, right? Half into base into height. So, that is how we get our formula of triangle as half into base into height. So, please write this down, whatever we have studied right now. You can pause the video, write it down, because this will give you an innate understanding of the subject matter. This will definitely help you in solving different problems in different spheres of life. Okay. Now, from this formula we can get some other formulas related to some specific types of triangles. So, we are going to go into that. So, first we will discuss right angle triangle. So, in right angle triangle, what we have to do? We have to first draw a right angle triangle, right? So, A, B, C. So, if I have to calculate area over here, I know my basic formula is half into base into height. And what is my height over here? Height is AB. I am taking base as BC. So, half into AB into BC. So, pretty easy, right? We can see that in a right angle triangle, we can say that the area is equal to half into product of sides, which sides? Containing the right angle. That is how it is, right angle triangle. This was pretty easy, you can easily prove it. Next, we are going to go into equilateral triangle. So, let us go. So, what is equilateral triangle? Equilateral triangle is triangle which is having all its sides equal. So, in equilateral triangle, definitely I have to draw a diagram of equilateral triangle. So, I will draw a diagram of equilateral triangle. Looks good. A, B, C. I am taking this base BC. I have to take one base. if I want to use the formula, as we know, so area is equal to half into, here it is D, AD into BC. Okay. Now let us take that all the sides in equilateral triangle, all the sides are equal in equilateral triangle. So this will be like A, and everything is A, right? So I will take one of the sides at A. So in equilateral triangle, we know if you drop a perpendicular, we have already done this in our chapters, that is called triangle. So if a perpendicular is dropped from the vertex, then it divides the other side into equal two sides. Okay, so it basically bisects the other side, bisects the opposite side. So if this total value is A, then this will be A by 2, this will be A by 2. Clear? So easily I can calculate AD by Pythagoras theorem. How? See, if you consider this triangle ABD, then AB is the hypotenuse and AD is the height, or you can take this as perpendicular, one of the perpendicular. So AD will be is equal to root over AB square minus BD square. This is by using Pythagoras theorem. Now what is AB? AB is A, so A square. What is BD? BD is A by 2, A square by 4. So this will be, if you calculate this, this will come out to be root over 3 A square by 4. So this will be A square, you can take only A outside, out of A square. If you do square root, this 2 will go outside, this will be root 3 will remain inside the root, right? 3 will remain inside the root. So I have to now write down this values. So half into AD is root 3 by 2A, and BC, if you see this BC is only A. So here it is root 3 divided by 2 into 2, 4 into A square. So this is the formula for area of equilateral triangle. Okay. So this is how you get the formula. You please don't try to memorize the formula at this age, because at this point of time in your life, or rather career, I would say, okay, at this point of time in your life, or rather career, I would say, taking this kind of memorization or one kind of rote memorization in pressure into your brain is not good. Okay. At this point of time, you should concentrate more on derivations rather than remembering the formula. Remembering a mere formula will not give you any value addition in your life, because that formula is also available in the data book, in the table book, in the formula book, in the internet, everywhere. Okay. But if you know how to derive, if you know how to derive the formulas, if you know these methodologies, this nature of finding out is not available in any place in the world, that you need to build. Things are very virtual, but these virtual things needs to be built up. This is not available. You can say, sir, derivation is available in the book in various places, correct, but you doing the derivation, your urge to do the derivation is not available in any book. That is what you need to develop. Okay. So now we are going to do another triangle, that is isosceles triangle. So isosceles triangle means two sides are equal, and here also we have done earlier the in triangle chapter. There is a chapter called isosceles triangle, where we have already done this, that if you drop this perpendicular, this will again break this sides into two equal sides. And so I'll again assume that this AB is A, this AC is A, so this one will be different, so this will be B. So if you take this as D, then BD is equal to DC is equal to B by 2. Okay. So, one by one we will go. Again you have to calculate area. So, area will be half into BC, that is base, into height that is AD. So, again here you have to calculate AD. So, first I will concentrate on how to calculate AD. So, AD will be calculated by the same method, Pythagoras theorem. So, here the hypotenuse I am using directly, hypotenuse is a square. So, I will write a square minus the base part. So, this BD is B by 2. So, B by 2 square. So, if you do this, you will get 4 a square minus b square by 4. Please do not copy, do this, find it out. So, AD will be, this 4 will come out as 2 and the 4 a square minus b square part will remain in the square root. What is BC? BC is B and this AD part is 1 by 2 root over 4 a square minus b square. The final formula is B into root over 4 a square minus b square by 4. This is the final formula for isosceles triangle. So, if you see in this lecture we have done equilateral triangle formula, we have done formula for right angle triangle, we have done formula for normal triangles. So, if I really want to understand that whether we should remember all this formula, you can say that remembering this formula is okay. Yeah, I also agree you have to remember one of the formulas, that is perfectly true, but do not try to remember this formula. There is no point remembering this formula. I hope your sane mind have already gone through it and agreed. Even remembering equilateral triangle formula is not that tough, but even if you do not remember and start deriving it from this age, and you, even if the problems come, you just derive it in on the right hand side of your paper, I think that is okay. That is nothing wrong. There is no need to show your memory power. Next, isosceles triangle. If you see this formula is a little difficult to remember. I am not saying it is impossible, but definitely little difficult to remember, that you have to agree with me. So, why remember this formula? Just derive it in the time of the examination. Somebody may say you may not find enough time to derive this in the examination. I do not agree. At this point of time you get a 2.5 hours for your mathematics examination for 80 marks. I think you have ample time to derive this formula. Hopefully you liked and you have noted down everything. It is not about only your liking. You have to note down everything that is being taught and work on it, apply it, so that you can get good amount of confidence in the chapter. So, we will come up with next lecture on triangles, and the topic will be nothing but the very favorite Hero's formula, or sometimes called Heron's formula. Thank you guys.